Hello there everybody. Today we'll be doing postfix to infix. In this problem we have a postfix string. This is a postfix string where we have our operators and we have our operands. What happens is that we will process postfix using a stack where B and C are the operands. We add those two together and then we take that and add it back to the stack and we add A plus B plus C, as you can see here in this output, which is our infix output. So some of the things that we need to look out for are the edge cases, and we need to ask clarifying questions to make sure that we are on point, we're solving the right problem. And one of the inputs is an empty string. What happens if we have an empty string? Should we return? What should we output? I think we should output nothing, and that should be the correct case. Another thing that we should look out for is a single item. A single item would be like an A, and the output should be A. And one more thing is that if suppose we have the operand just a plus sign, that should return us an error. Like, that should not happen. We should just assert that this is an error and we do not process this. So like, I had some code earlier and this was the index error that I was thinking about doing, but I don't think that that's the right way of doing it anymore. I think I should just make an assert statement and say exactly what the problem is. And the problem is this is improper input. Improper input. Okay, right. So I think our output should be something like just error. Assert the error though. We should assert it. Okay, so let's get I think that covers our edge cases, and our time and space complexity should be O of n, because we do need to go through every item in the string, and we do need to store the entire string afterwards. So with that, we are ready to make a match. The match is going to be a stack. That's because that's what we need to use to process the items, the postfix, properly. And let's plan that out. So here's the plan. We're going to go through each character in the string to if operand, then if it is an operand, then add to stack 3. Otherwise, it is operator. So pop 2 operands from stack for processing. And 4, add joined operand back into stack. We do need to handle the cases where it is empty. So handle empty string and handle, we also need to handle the lack of operand. Okay, so that's our plan. We have that's good that we have so much information. Let's implement it. So first things first, we'll define postfix to infix string. One thing we did not define is what is exactly an operand that we want to input. An operand should be A through Z. So anything between A through Z is operand. So for C in S, if C dot is alpha, it's an alphabetical character, we're good to go. So that means that if it is, then we need to insert an item into our stack dot append a character. So we did not create our stack yet. Let's create that stack. We also did not handle the empty string, so I do think that we can handle that later, or we need to handle that now. But let's handle it later and let's move it down our plan. So go through each character. If it's an operand, add it to stack. Now if it's else, so this is else statement. It's an operator. So a first one, our pop is going to be a right operand is equal to stack.pop. One thing we need to manage for at this point is the pop, because the pop itself can cause a problem. The problem is going to be that that we do get an index error, and how we can avoid that is if not stack, then we could just say, well, assert false. Okay, so now the operand is we're gonna create the string that we need to add. So that's going to be this string here with the 2 parentheses, and we're going to add our first right operand on the right side, and then we're going to add our left operand on the left side. So this left operand is going to be on the left side, and we have our operator, which is C, and that should be good. If anything, we'll make adjustments later. And with that, we have our operand, and let's add it back to the stack dot append operand. And with that, everything has been appended, and we can return the stack at 0. But of course, that would cause a problem if there's nothing there. And stack.pop would cease to be if there's nothing there. We would return, it would be bad because we would not have handled the empty string issue. So to handle the empty string issue, what we should do is just be like, if not stack, like right here, then like return none. Okay, just return none. Just return the empty string, actually. That's better. Return the empty string. So we can return this in one line. So stack.pop if stack else empty string. So we could also just do that as a single item, so it looks just way better. Okay, anything else? I think we handled all the situations that we need to handle. So let's do a review, right? So to do the review, let's use some of the cases that we have seen here as our input and outputs. And so let's just put it in. So this is our string, and what we expect is this particular output. And as you can see here, the A goes into our stack, and then what happens is then B goes into our stack, and then C goes into our stack because they're all, you know, operands. Next we see a plus sign, and we don't check if the input is going to be a proper operand, a plus minus, but anything that's not alpha is going to be operand. And so now we're going to do a right pop. Right is equal to C and left is equal to B. And now we're going to add these operands together. So we have B and let's say a plus sign and then the C. And we have these parentheses added back to it. So we add this into our stack. See? So now when we take the right out, we get that b plus c, and then left is a, and when we see our next operand, right, we add that together and we have a plus b plus c, and we have the new parentheses by its side, right, and that will result in a good answer. Okay, I think that looks pretty good, and let's just do the empty case, just to be, go cross our x's and dot our o's. So that's going to give us a none, because as you can see, if there is nothing in our stack, then we'll just return nothing, right? Perfect. So with that, I think we will get that. Let's get that error as well, and that single item. So that single item is an A. Let's just do that. And the error is at the end. The error is going to be a plus sign. Let's run it. So as you can see, we plus the C here. So as you can see here, this is correct. We have the A, and this is an empty. And we tried to print the plus sign, and that gave us an error when we asserted false on line 12, which we thought exactly what we should do. So now we do have like one more test to run. This is the plus sign down here. Let me just grab that for you. So let me just grab this. And let's test one more thing before we evaluate and complete this problem. So the evaluation is, as I said, it's going to be O of n, because we do have to go through every single item. Looks like the error is going to stop me from running this code. So I'm just going to remove that, and there we go. Another way to handle the error is just to return it, and then we don't get an error, but that's not right, because or we can say, oh, if there's an error, we'll return nothing. That's specified to our code. Okay, so with that, I think we are ready to just send this off with an evaluate. And that's, again, O of n, n for length of string, and O of n, time, because process the entire string. And the space is to create the entire string plus 2 for every operator. Okay, so that's it. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below, and I'll see you in the next one.